channel, and today we are going to solve merge sort. So merge sort is a divide and merging algorithm. So in the merge sort, what we will do is we first divide the array in small parts against single array parts, and then we merge together and form a new array. And this array will modified and this array will sorted. So we are giving a array and its starting position and ending position. So starting position is this 0th and ending position is 4 last position, and we have to sort the array using merge sort algorithm. So yeah, so you can start by this example. This is a array, unsorted array, and what we will do is this is unsorted array and this is the index of the array. So first we will divide the entire array into small parts. Uh, this is 5 8 4 12. You can register by this. This is L and R. This is midpoint. So we have divided L to mid single part, and mid plus 1 to R is another part. Then what we will do is we have to divide this 5 8 and 4 12. We have to divide this 5 8. And now this will not further divided, so we will stop. So not further divided, so we will merge. 5 8 and 5 come first, 8 comes second. Now 4 12 is divided, then 4 comes first and 12 comes second. Now these both are divided, so 4 5 8 12 goes there. So we will first divide, then we are doing merging. 4 5 8 and 12. Now we go to this array, and same steps we further divide it until it will be a single array, and now we will merge it. Same with this, we will divide it, then merge it. Now merging the all the array. Is become 2 3 5 7. Then we merge these two arrays, 2 3 2. Now we will compare this and this, which one is greater. 3 is greater, 3 is smaller, so 3. Then 4 and 5, 4 is smaller. Then 5 and 5 take both of this, 5 and 5. Then 7 and 12, 7 is smaller. Then 8, then 12, and the algorithm finishes. Yes, so what we are doing first, we are finding the mid. First we are finding the mid, and then we are saying if what will happen. It will, in the last, it will become a single array with the L and R at the same position. So if L and R at the same position, then what we can say, we can close the algorithm. So return is, otherwise we are calling merge short, we are calling it from ARR L and mid. Another time we are calling it for merge short ARR m plus 1 till R. And in the last we are doing is merging. So we are merging ARR L mid and R. We are merging. So now we have to with the merge algorithm. So this is the merge algorithm. So in the merge algorithm, what we are doing is we are making one pointer here and one pointer here. So this is L and this is m plus 1. So we are making one pointer at L and one pointer is m plus 1. So L at start at L, and get m plus 1 position, and we are saying while until s is not equal to m and e not become r, we have to iterate, and we are saying if ARR of s is lesser than ARR of m e. So we are saying that if this one is smaller in both of these, then this one goes in the array. So if ARRS is lesser than or equal to m, then if we are storing the vector, you can store also in arrays or list, or you want to store. Now I am saying answer dot pushback, so it's storing in the vector. We are pushing the element in the vector, and ARR of s is pushing in the vector, and then we move in the next. So here, then here, else if it's not, then ARR is smaller, so now push ARR of E in the array and move E further. But it's better. Yeah, so yeah, so 2 and 4, 2 is smaller, so this one is smaller, so this will goes in this array. Now check 4 and this 3, 3 is smaller, so this 3 is goes. Now 4 and this 8, so this 4 is smaller, this is 4 will goes. Now 5 and this 8, 5 is smaller, 5 goes. Then 5 and 8, this 5 is smaller, 5 goes. Then 8 and 7, this 7 is smaller, 7 goes. Now this array is completely lost, so this condition ARR is lesser than equal to R executes, and we will, I mean the loop, we will out of the loop. Then what we will do, if there are elements left in this array, then we have to push in the array. If there are in the vector, and if there are elements left in the array, then we have to push these elements into vector. So while s is lesser than m, then we have to push the remaining element in the array. So push remaining element in the array. And there are remaining element, then push in the vector. And in the last, what we have to do is we have to modify the array. So for int, so it's where to start the for loop. One thing, so L, M, and R. So we have to start. So now, if we first take this, then we can say that this is L and this is R. We have to iterate till L and R. So we have to iterate till L, I less than R, and then I plus plus. You can say that we have to start with 0, because every time this is not 0, because sometimes you have to merge these, because starting you will see that we have to you are dividing, so this will become 2 arrays and this will become 2 arrays. Then this here is L, so we cannot say that L is always 0, so you can't take it L I equal to 0. You start I equal to L, because I sometimes here, I sometimes here, I sometimes here, I sometimes here. That's why getting I equal to L, or always this is there is R, so getting R, and I'm saying it ARR of I. ARR of I is nothing but ANS of, you have to start with 0, so I minus L. Why I am not using why I am using I minus L, because if you have to make answer 0, answer 1, answer 2 bit, but ARR is changing, so ARR of this palace is changed and this palace is changed, but answer is always 0 or 1. So I am saying I minus L, because I is into this, so this will go to 10. Yeah. Now run this. There is some error. Let's see where is error. So 11377 and 13479. The expected output, and our output is 11377. So it will miss 9. It will miss 4, 5. Let's find out. So first we are finding mid. We are saying if they are equal, and then we are calling to L to mid plus 1 to R, right, and then we are merging it. These steps are correct. Now we are merging, so we're saying vector int answers s is L, e is m plus 1. Then we're saying if s is less than m and e is less than r. Then if we are saying if ARRS and ARRERS is lesser, this will be lesser. Then we can say that we have to push this and we have to move here. As if it is greater, then we can say that we have to push E and E plus plus. If ARR is greater than ARR is lesser, then we will say that we have to push ARR E, and then we will from that T here. It's alright. Then you're saying if S lesser than equal to M, then we have to push ARRS and S plus plus. Other we have to push ARR E and A plus plus. And we are running loop to L to R. I was in ARR of I, because In the case of this, it's zero, I it's zero, but in the case of this, I is not zero, so the error I in the answer of I minus L. So I think this for is correct. If I there is some error, let's find out. Let's see. So it's mid, first find mid, then it's our return, then merge. Delta made because one to R, then merge script, then merging function. Answer SL ER. So there is error. So yeah. So we solve this and ARI equal to answer of I minus L. So